We will start. First of all, it would be a Linux oriented training. I mean, it would be the Linux machines that you are going to work on throughout this training. So it is very important that you have some basics to Linux, basic idea on Linux. Even if you are kind of new to Linux, don't worry about it. We are starting from the Linux basics, but make sure that you spend more time on Linux initially to get yourself used to Linux, because that is very important as we move further, right? So initially, first couple of days, I think 2 or 3 days, it is going to be Linux basic commands, then some user management topics in Linux, and also some file permission stuff. And after 2 or 3 days, we will move on to our advanced topics. That would include scripting. We are covering shell scripting as well as basic Python programming. Shell scripting we are actually covering in depth. That is nothing but the Linux shell scripting. On the Linux command line, you can actually do some scripting. That's what we are going to focus on, which is kind of very important for a DevOps engineer. I mean, when you work with Jenkins or when you work with a config management tool, it is very important that you have to do some kind of automation yourself, right? Sometimes some tool would need you to write some script because probably there is no proper strategy inside that tool. So the scripting is kind of important, but really you don't really need to be a full core programmer to work on DevOps. That is not the intention of DevOps. You need to do some automation. So for that you need to learn some scripting. So don't worry if you are not from a programming background. That is not something you need much, but a little bit of Linux background is what you need to have to start with. And then we will cover some Python programming. It's not a basic Python program. Actually, we are focusing on those portions which are relevant to you, which are relevant to a system administrator or a DevOps engineer or a cloud engineer, right? We would be learning some object-oriented programming concept in Python and also some module concept in Python, which would hardly take 4 to 5 hours. The hours that you see here can be little misleading. Actually, I prepared this slide little long back. So after we are done with the programming training, we will move on to some Linux system administration training. This is also very important for to start with DevOps. You need to have a good understanding about software. What is a software and what is a web application, and how you can run a web application in a Linux environment, right? How these web applications can connect with a database, what is a Java application and how it runs, what is a PHP application and how it will run on a Linux environment. Then how you can have your own website and run that web application on your own website, just like Flipkart.com or Google.com. I mean, that is nothing but a web application, right? Flipkart.com or Google.com, when you browse for it, what you see in your browser is nothing but a web application. Web application is nothing but a software that is available to you through an HTTP URL. You can go to that URL, then use that software. In Flipkart, you can create your shopping cart, you can log in, right? Many functions, you can make payment, you can become a prime customer. So there are many features that are offered by that company that you can rely on, that you can use. So you are the customers of Flipkart. So like that, you can actually set up your own application. Maybe it can be developed from PHP programming or Java programming, doesn't really matter. And that is what it's very important. Actually, don't consider it is as a prerequisite. It's actually the very important training that you need to take before we start with the advanced cloud computing or DevOps training. After we are done with the Linux administration, we will move on to some networking basics. Basically, we would be covering the DNS, like I said, how you can run your website on this web application, and also how you can set up a network infrastructure and how multiple machines connected to it. And all these machines can have different architecture on the networking side. So we will see how you can set up a traditional networking system, which is very important before you start with the cloud. So these two topics are very important, especially if you are new to Linux. You should have a good idea on the networking and system administration part before we start. Then we will move on to cloud computing, which is we are focusing on Amazon Web Services, AWS. Right? It would take nearly 17 to 20 hours. And these are the different AWS services that we are going to cover: EC2, elastic load balances, auto scaling. So I will talk about these services in a bit. So these are nothing but some services offered by this cloud computing provider. The AWS is nothing but a third party cloud computing provider. On their platform you can build your infrastructure, which we will see. I mean, that is going to be our first project in this training. Our training would include total three projects: one into cloud and two into DevOps. Right? Into cloud, what we are going to do is we'll build and design an infrastructure, and with the software application that we learned in the previous chapter, we would be deploying that software in the cloud infrastructure that you design. So your cloud infrastructure would serve your web application to your customers. So we will talk about that project in a bit. And after cloud computing, we will move on to DevOps. And these are the tools that we are going to cover during our DevOps program: GitHub, GitLab, Apache, and Jenkins, Docker, Nagios, Chef, Puppet, and Ansible. So we would be covering Ansible in depth, and Chef and Puppet, it's going to be just a brief and comparison with Ansible. And mainly, I mean, all these three are similar tools which are used for config management, and one can replace the other. So it's important that at least one of these tool you should be an expert with, which is very critical topic. And also Jenkins and GitHub, these are also very important topic that help you achieve the continuous integration, which I will talk about now. And we have some monitoring topic, Nagios, that is also a detailed topic that we are going to cover. Then containerization using Docker, which is we are not covering in depth. Actually, we are not covering those orchestration topics. We would be covering only the administration topics of DevOps, which is a intermediate level training, not an advanced, neither a basic. So the remaining topics we are covering in detail. And for DevOps, it would take nearly 30 plus hours. And at the end we will have one class that would discuss about your future plan, one or two classes to discuss about your future plan and building your resume. Then relating your project that you have done into the real-time project. I mean, I will talk about how it would look like in real time. Actually, the project that you are going to do would are kind of real time. I mean, those are the project which I work in. A kind of replication of this project is what you would be working in. And at the end, there would be some interview specific sessions we would be conducting, two or one or two sessions. And also what are the next thing that you want to learn if you like. But whatever we are going to cover are good enough to, if you are, especially if you are looking for the knowledge side, or you are looking for clearing an interview, whatever topics that we are going to cover in the training are going to be good enough. Especially if your intention is to get finding a job, don't focus on any extra topics, but stick make sure that you are very clear with this project that we are going to do, and also very clear with the cloud computing topics. That is the main intention. So I will talk about cloud computing. So, Azure we would not be covering. We would be covering only AWS, Amazon Web Services, in the cloud computing portion. So Azure is not in our topic list. For if you are from an infra background, for now you don't need any prerequisites. Actually, you can start with the training. Even if you are from a background which is not based on Linux, still it's okay. But only thing is that put your effort. I mean, get yourself used to the Linux command line and learn as Linux administration very well, complete all the assignment. That is good enough to get you started with Linux. So um, don't worry about it. But a Linux knowledge, if you have it, it would be very much helpful, right? Instead of and can you teach Maven, it should be okay. We can actually, that is something I already have in my mind. We will talk about it. How much Linux is used in DevOps? Actually, there is no relation between Linux and DevOps. First of all, make a note. Linux does not have any direct relationship with DevOps. They are actually completely different topic. But when we talk about DevOps, we are also talking about a software infrastructure that we are going to work on. That would include a lot of Linux machines, and also these DevOps tool that we are going to learn. They most of them run on Linux. So when you want to work on these tools, you are actually going to work on Linux command line to manage these tools. So there are many reasons you need to know Linux to work as a DevOps engineer, which is important. Yogesh, those what you see in the list is what we are going to cover, right? And the DevOps that we are going to cover, they are not specific to AWS. They are actually uh, common, common for any infrastructure. So, first I will talk about what is cloud computing. Okay, let's think about this. Think about an infrastructure, a software infrastructure owned by a company. Think about Flipkart, right? Or any startup company or any company who has a web application as their software. They also need an infrastructure where the software will run, right? That is important. That is the case with any companies. Even for startups also, they would need infrastructures that would contain nearly 500 or up to 1000 machines. Even small companies I'm talking about, maybe for Flipkart, they would need thousands of machines in order to manage all their customers, because there are lots of customers browsing for flipkart.com. They need a powerful infrastructure that could contain thousands of machines. Even for startups also, they would need hundreds of machine part of their infrastructure in order to serve their software. So I will talk about such an infrastructure which is serving a web application. Think about a infrastructure that is connected through a network. This is a network, right? And inside this network you kept a number of machines. Think about Flipkart. Think about this is a infrastructure owned by Flipkart. So there are a number of machines part of this infrastructure, and you as a customer of Flipkart, when you browse for the flipkart.com website from your browser, this is you browsing for flipkart.com. Probably first you will get connected to one of the machine part of the infrastructure, and that machine would give you the front page of Flipkart. You will get the web page flipkart.com from this machine, which would get displayed in your browser. And it is probably a static page where you can see a lot of flash sales and many things, right? Some the front page of Flipkart. Now you click on the sign in button and you try to log in with your mail ID and password, and probably this is a database machine to which this machine would connect to. Basically this machine want to know whether you entered the valid email ID and password. So what this machine does is it would contact a database machine. It would check what is the username and password that you have provided, and it is matching with what they have in their database. If it is matching, then it will allow you to log in. Now you are logged in. Now you want to create a shopping cart for yourself. You try to select some item to create your shopping cart. Then probably the request would go to a different machines. This is a machine which is running the respective software component that would create the shopping cart for you. So the shopping cart get created by this machine, and you can see that shopping cart in your browser. Now you want to make a payment. Probably you get connect. Then when you click on the payment button, probably the machines would connect you to a different machine, which will take care of the payment gateways, connecting to the right payment gateway and making the payment. So what I'm trying to say is, for any web application or any software, the infrastructure can contain different machines serving different roles, right? This is a machine which would give the users the front page and manage all the requests coming from the users, and these are other machines that work with this machine in order to give the user what they are looking for. So one software component is installed in this machine that would take care of giving the page to the people. some software component is installed on this machine which will take care of the shopping cart creation. So this machine is integrated with the payment gateway with using some software module. So all these machines are running different software, and all these software are developed by your developers, right? And sometimes you will have some infrastructure requirement. Maybe this is the only machine that you want people to be connecting from outside, and all these other machines should be communicated internally, right? These connections should not go through internet, it should be internal connection. So probably you want a private network configured between your machines. Maybe you want to split your machines into different subnets. So there are many things that you want to do in so if you have to set up such an infrastructure for yourself, there are many things that you need. You first of all you need a building, right? First of all you need a building, and inside that building you want to set up a lot of infrastructure things. You need to buy the routers, network cables, network devices, and have all the machines connected to the network. And you need to buy these machines, and these machines are very important. They should be running 365 days 24 by 7, right? So the machine should have very good powerful hardwares, and the machine should be installed with some operating system, maybe Windows or Linux or any other operating systems. And these machines will be running your software component, and you should have good network connection between these machines, and the building also should have good internet connection from a local third party. Maybe not one, you need internet connection from multiple providers, because at any point of time one connection can go down, then other connection should automatically pick up. So there are many things that you need, right? Then you also need um, then what else you need? You need good ventilated AC in the building so that the machine does not get heated up. Then you need good power backup, because you cannot afford any kind of power problems inside this building, because if any of this machine goes down, your customers are getting dosed. I mean, they would be denied the service. So there are many things you have to take care if you have to manage a building or a infrastructure of yourself. So this is something especially the startup companies cannot afford, right? And also you need to take care of a lot of physical security, right? You need to have physical securities to limit unauthorized access physically. Then also there should be proper access system, right? To make sure that authorized people are going inside the data centers. And also it should be free from natural disaster. I mean, the building should have good capability to stay in a earthquake, in the event of any earthquake or any natural disaster. So there are many things that you need to take care, which is not something which is very costly. First of all, it's very costly, and it is actually a big headache if you have to manage all of your own. So what AWS provides you is a global platform spread across multiple countries. Or maybe you want to build an infrastructure in Mumbai, you can select Mumbai as your region and build an infrastructure there. Maybe all you need to do is just click on a button inside AWS portal to create a network. And you want to split this network into small subnets. Again, click on other set of button, and the network is split into different subnets. Now you want to create a number of Linux machines in here, you want to create a number of Windows machines in here, and then you want to install or deploy your software in these machines so that these machines would start serving your customers with your software. You can do that. Then you decided that the machines in this subnet should give direct internet connection. People should be able to connect to those machines. Maybe these are the machines of Flipkart that would accept connection from end user browsers directly, right? When you browse for flipkart.com, these are the machine that would serve this user. So this machine should be facing the internet. I mean, people on the internet should be able to connect to these machines. So for machines in this particular subnet, you want to give have them internet access, and also people from outside should be able to connect to these machines. And these machines, maybe you are running only databases, then you don't want internet connection of the machines in this subnet. So like that, you can configure different things, and you can actually build a infrastructure in the cloud. Most of these components part of your infrastructure are virtual. I mean, the network is not an actual network, but it look like an actual network. the machine that you create are not actual physical machines, but actually they are the machines running inside actual physical host, but they look like a physical machine. That's what you care about. So you get an infrastructure that look like real, and you can serve your customers using that infrastructure. That's what you care about, and you get a lot of benefits and flexibility in order to configure this infrastructure. So that is what we are going to focus on, and that is going to be our first project. We will take those web application that we learned under Linux administration, and we will deploy those application in the cloud infrastructure that you designed. That is going to be our first project, and your infrastructure will have these properties. It would be scalable. What it means is, even if there is a problem inside your infrastructure, or I mean if there is a drop in the traffic, there's a requirement that some campaign is going on your website, the Flipkart big billion day. On that particular day, you need your size of your infrastructure to be maybe 5 times, uh, right, 5 times multiple than under normal conditions. So you want to add automatically a number of machines to your infrastructure when you are in need, so that your infrastructure will take care itself. It would be self-serving, that whenever it find there's a demand for high traffic, it would add up more machine to this infrastructure and handle those traffic, and when the traffic is back to normal, the extra machines will get deleted, so that it would save you some money. So this is also possible. And high availability and fault tolerance, basically what it means is, it doesn't really matter what happens inside your infrastructure. Inside your infrastructure, anything can happen. Maybe the connection between these two machines can break, or this machine can go down, or some other database machine can go down. So anything can happen in the infrastructure, which is not something that you can control, and it is not something which AWS can control either, right? It can happen. It is internet, and it can go down at any point of time. But even if something failed inside your infrastructure, the software that you are running inside this infrastructure would become available to your users always. That is done through some high availability and fault tolerance configuration, which AWS provides. So we will be going to cover that in detail. Right. So the infrastructure that you are going to design in the cloud is going to be scalable one. It would be highly available, and it would be fault tolerant. So we will take a deep dive into that when we learn AWS. And once we are done with AWS, we will move on to our next topic, DevOps. So I will just give you an overview about what is DevOps. Uh, then we will just, I will take your questions. So now take a short break of 5 minutes. We will continue and talk about DevOps after a short break. Take a short break of 5 minutes. So I'll talk about DevOps. So first I will talk about this continuous integration process. Okay. And that is going to be our first project in DevOps, the continuous integration. So first we will talk about a software. So again, please remember, we would not be focusing on the coding part. That is not something we are going to focus on, but we are actually focusing on delivering this software to the market, right? Those are the things. So starting from the change in the software code, how it would become available to your customers, that's what we are going to see. How it can be done through a series of automated pipeline process. So let's take a look at this scenario. You are inside a company, and a software need to be changed nowadays. That is one important requirement for any software. A software which is in the production, or a software which is in the market, should get frequent updates based on the requirement from your customers, which is the most important thing if you want your product to succeed. Nowadays it's very important because there are too many competitors in the market, so you need to compete with them, or you could be able to beat them, right? So that can be done to give dynamic updates to your software based on what software want today. For example, Flipkart, right? Amazon is offering a lots of features, and Flipkart want to compete with them, right? They want to, they should be able to give the same price or discount offers, and they should be easily able to work with their stock items to give discount to the people. So there are many things which Flipkart need to take care if they want to stay in the market. That's the case for any companies. Think about Uber, Ola. There are many competitors for any kind of business. So it's very important that if you want to succeed in business, you should be able to give to the people what they want, right? So think about a company, maybe a retailer company, or think about your software that your company manages. The software need changes, right? Software need a lot of changes, which can be, maybe one change can be, some people are not able to log into flipkart.com with their Facebook account. There is some Facebook integration that allows Flipkart customers to log in to flipkart.com website using their Facebook credentials, but that is not working. Somebody tried to log in using Facebook, but they are not able to log in. So that would be generally identified by your testing team, and that would be opened as a change request to your developers. So a lot of change requests, such change request would come to the developer to make some change to the software application. Sometimes what the retailer want to do is they want to give some prime customer option, so that selected customer who are prime customers would be getting more benefits than the ordinary customers. Maybe they would be able to get their deliveries fast, right? So many things. So they want to make some change in their software so that people can become a prime customer by paying some extra premium. So this is another change request that come from the marketing team. They found that if we get more prime customer, we are going to generate a lot of business from those prime customers. So the marketing team opened a change request to the developers asking them to implement this new feature in the program. So like that, there can be a lot of change requests that would keep on coming to your software. And generally every company will have some system using which they can track the change request, maybe some ticketing system or something called Jira, or it's through a web application. They can open this change request and developer can see those change requests and they can start working on them. So assume there are a number of change requests, and individual developer would take the change request and they will work on this change request. Working on the change request would mean they are making some code change, right? The software was originally developed from some programming language, so they will have that source code in their laptop. They would work on those source code, make some code change, and finally they will deliver this code change to some place. Maybe assume this is a storage place, or I'm going to call it a repository, which would actually track whatever change happening to the source code. So assume this is a smart storage that already contains your latest software code, and any developer, whenever they make some change in the source code, they would make a commit to this central place. So this central place will have updates coming from different developers. So whatever change are happening to the source code, it would be updated to the repository, and repository would also record each and every commit. So this is a developer called Tom. So what change he has made, at what time this commit is made, and which files did he modify, and what are the exact lines that were modified. So everything, whenever any developer make a commit to this repository, the repository will track all the changes that they have done. So the repository is nothing but a source code management tool. The code, the plain text source code written in PHP or written in Java or written in different programming languages, they are saved inside this repository. And I talked about the product infrastructure, right? That would contain a number of machines that are set up in a cloud. Maybe it can be set up in a cloud, or it can be set up in your premises, right? On your on-premise data center. That is also fine. So these are the machines which are actually running the software. Whatever code change that developer had made should be moved into this infrastructure, because this is the infrastructure which serving your customers. So somebody who is browsing for your retail website, they are getting connected to one of these machines, and this is the machine which is giving them the front page. So all these machines would be running different software components. So whatever change that comes into this repository should be moved to this production infrastructure, which is very important. That is when you can say you are in the market, or that is when you can say your customer can see the changes, right? Now they can see an option, the Prime membership, or they can now able to log in using their Facebook account. So it is very important that whatever change that are happening inside this repository should be moved to the production infrastructure. This process is called release process. So every company will have some kind of release process. Maybe they do it every month or every 2 months. So what it means is whatever change that are there in the repository, the latest changes of the last 2 months will go live. That means that would become live on your website on this particular date when you do the release. So a release is nothing but a process of bringing the changes done by your developers into the market. So, but due to various reasons, this process is very slow, right? In any company, this process is very slow. There are many reasons for that. I mean, sometimes whatever change developers are doing, first it need to be tested. First of all, it is not the plain text code that you copy to the production infrastructure. The code need to undergo a lot of process. So think about this. You have your source code located in here in the Git in the repository. So the plain text code is not in a understandable form. First, it need to be converted into an executable program, right? Convert these source code into some executable files. You would use some build tool for that, and or Maven. Using some build tool, you would convert this source code into some executable code. There are different build tools that you can use for this purpose. And these executable files is what you want to run on your production infrastructure machines. But again, that is not something that you do directly. You would not simply take the code from Git and run it on your production. Before that, probably you want to, there are lots of executable files belonging to different software component. There are lots of executable files. Probably first you want to save them inside a centralized place, maybe a repository that would contain different software component in a ordered form. And once it is saved here, you want to test them, right? You want to make sure that these executable files are actually executable. I mean, you will try to execute them, make sure that it is working fine, it is doing their job. And also some unit tests that you want to perform. Sometimes this developer made some change, maybe they included the Prime customer, so developer added some classes in the program, so you want to test some functionality inside that class. So you want to perform some kind of unit testing inside all these executable files and make sure that they are stable and secure. And once these executable files are saved in the repository and they are organized, this executable need to be running on a infrastructure, right? But again, this is not a production infrastructure. First, you want to test these executable files. It would be a testing environment that would contain a number of machines, but it will look like a production infrastructure. It is not. I mean, this is not the infrastructure to which your end customers will connect to. This is one infrastructure which would be installed with the same software component as production, but only your internal team can connect to it. Maybe your internal team can point their browser to this infrastructure. They can browse the retail website. They will try to become Prime customer. They will test if it is working or not. Then they will also try to log in using their Facebook credentials and make sure that it's working. So everything, every functionality and every integration parts are tested. So we will talk about testing in the training. I'm not going to talk about it. There are different types of testing that you want to perform. So all the testing need to be performed. If everything is looking good, probably the next thing that you want to do is generate a report. And again, this report generation is also generally nowadays it is done in an automated way using some automation testing tool. You test it and make some automated reports. These reports need to be verified. If the reports is looking good, probably the next thing that you want to do is uh, bring those table changes, right? The report is looking good. What it means is the change done by the developer is looking good. A developer made a change to the repository and that change is working fine. So in that case, probably the next thing that you want to do is set up a new infrastructure. Again, this would not be production. This would be again another testing environment that would be installed with only those stable components done by the developers. Only those stable executable files would be set up inside this machine, and again further testing would be performed and further report generation need to be performed. If that is also looking good, probably the next thing that you want to do is maybe go to production. So this is not exactly this way, but kind of just wanted to give you an outline. So this is not very easy, as you may have figured. Doing all these things manually and doing the release to production is actually a complex stuff. Each and every change developers are doing should undergo all this process, and there can be a lots of change within 2 months. There can be hundreds of changes different developers would be doing on your software. So all these hundreds of changes need to be tested and verified before you do the release to the production. And sometimes when the testing team do the testing, probably they would be doing the testing after a week or something, and a report would be sent back to the developer, and at that point of time developer will have no idea which why this is failing. Maybe a testing team would say we tried to check some payment but it is failing. So at that point of time, probably developer would have made some 10 changes already. They have no idea where this problem comes from. So they need to go through a lots of logs and they need to find out the problem, which is kind of difficult after 1 week. And also the operation team, there would be some operation teams in every company. They are the ones take care of this production infrastructure, and their responsibility is to make sure that the production is stable and secure. And they would even compromise on stopping a release if they believe that the release can break production. So they are mainly focused on the infrastructure part because they does not have too much idea on the development or software component area. So unless they are very sure that this release is not going to break production, they will not allow the release. They would request the test reports from different teams, make sure that it's working fine in different environment. Unless they get these reports, they will allow the release to be performed. And sometimes they will also, sometimes the developer would say, please do these manual changes this time. When you do this release, then operation team would say, no, it should not be any manual change. It should be go through the process. So due to this conflict, the release process slows down. And that is the case for each and every organization. So these things need to be taken care, right? To make sure that whatever change developers are doing, the so that is one main reason DevOps has evolved over time, right? So DevOps solve this problem by building a software pipeline through which each and every change done by a developer would go through. So I will talk about such a pipeline process. Let's think about this. There are a number of developers and they keep on making some change to this repository, the source code management tool. So whenever there is a change in the source code, we will be taking a sample project, we will be taking a sample Java project, and we will be doing this continuous integration process. That is going to be your first project in DevOps. So what I meant to say is you are going to get good amount of hands-on. So think about this, all developer, whenever they make some change in the source code that is received by the repository, and repository send out some notification to some tools, maybe some continuous integration tool, let me call it Jenkins. So this is some continuous integration tool. What this tool does is, it would take the code from the repository. Whenever it find that there's a change done by any developer, it would take the code from the repository, then using some build tool, maybe Ant, Maven, Make, or there are different build tools. Using one of these build tools, this Jenkins would convert this code into executable form, and later this executable code is actually saved in a binary repository where it is better orchestrated. I mean, it is saved in a better coordinated place. And Automatically, once all executable files would become available in here, the next thing Jenkins would do is it will deploy a test environment. These executable files will run on these machines, part of your testing environment. This is where your testing team want to do some kind of test. Okay, before that, Jenkins also want to manually execute all these executable files to make sure that it's all looking good, the execution is working fine, that it want to test it. And once it is tested, next thing that you want to do is deploy all the executable in a testing environment, and again send some notification to some testing tool. It's a automation testing tool that contains a number of scripts. Probably Jenkins would say, these are the script that you need to execute now. Then all the script would be executed inside this environment, and automatically a report would get generated, and Jenkins would see this report and verify this report. And if the report is looking good, what Jenkins would do is, okay, it's all looking good. Whatever change which this particular developer had made did not break the system, and also change done by the developer is working fine. So it is going to be a stable change. In that case, what Jenkins want to do is maybe copy this change to a different repository. It's actually not a different repository. It's actually a different branch within the same repository. So I'll talk about that in detail when we learn the training. Right now, that's not required. But if there are any problem, Jenkins would send a notification to this developer saying that after you made this particular change, something is broken. This particular report is not looking good. So please take a look. Then the developer would identify that, okay, it was working till now, but now it's not working after he made the change. So he can easily figure out what is the problem, right? So he will get feedback very fast. So one of the main invention of this continuous integration process, this is called continuous integration, verifying each change done by developers through a series of pipeline process which the code change would undergo until it get verified. If it is not verified, a feedback is given to the developer. He will fix it. He will again commit it. The change will again go through the same series of process until it is verified. Only the verified changes will go to the next level. So this is called continuous delivery process. It can go till the production, right? This is a different environment where you want to go through all the process again. Everything is working here, then you want to go to the next level testing. So this delivery process is called continuous delivery, and this verification of change done by the developer through a series of continuous process, it's called continuous integration. So that is going to be your first project. We will take our sample Java project and the PHP project and uh, achieve this continuous integration pattern in the project. We would be learning different tools. We would be learning some binary repositories also along with this, and some build tool, Git, GitHub, GitLab. These are the different source code management tools. It's all Git. It's all about Git, but different. Git, for example, GitHub is a hosted service. You buy Git from a third party. GitLab is something that comes along with some graphical interface. So these are different topics that we are going to cover. And monitoring Nagios and config management. This is our final project. So first project is into cloud computing, building and designing your infrastructure. Second project is continuous integration and continuous delivery. The last project is monitoring and config management, which is again, think about this. You have a large infrastructure that you want to manage that contains a number of machines, right? I told you, even for startups, there can be 500 to thousands of machines, part of their infrastructure. So how do you manage all these machines? How do you manage the configuration inside these machines? That would include which software should be installed in this machine, what should be the name of this machine, what are the services should be running on this machine, what are the files should be copied on this machine. So there are many configurations that each machine in your infrastructure need to follow, and it is kind of not an easy task, right? I mean, making sure that different machines are following different pattern. So your intention would be set up a config management tool, and in this tool you will write down the configuration. You will mention, I have these many web server machines, and on all the web server machines run the software and copy these files and everything. You write down how the machine should look like, and Similarly, you would also mention these are my database machines, and these are the different type of software that should be running inside the machines, and these are the database to be present on those machines. So how each and every machine part of your infrastructure should look like, you will write down in a single place, and the entire infrastructure would be managed from a single place. That is what I mean by config management. So we will take the same the project that we would learn, I mean same Java and PHP application that we learned in the previous chapter, uh, achieve config management in that infrastructure. So that is going to be your final project. So those are the different, and again Uh, at the end, we will have two classes mainly focused on interviews and how you would explain this project to your interviewer. All those things we will discuss. And also, if you want to learn more tools, what are the best place to learn them, and what those tools are used for, we will have an overview at the end. And yeah, that's pretty much. And all the classes would be recorded, and you would get access to the videos. It would be uploaded in a Google Drive to which you will get access. And yeah, make sure that those who are new to Linux, you should be very clear with these concepts. The Linux administration as well as networking is the most important topic that you should complete before we go on to the advanced training. So the classes are going to be from Monday to Friday. Initially, it's going to be at 8 p.m. IST. I think for first 10 days, or maybe right for first couple of weeks, it's going to be 1 hour per day at 8 p.m. IST. Later it would change to 9 p.m. IST, and the timing would be 1.5 to 2 hours per day. And once it changed to 9 p.m., I'm talking about, it would become 1.5 to 2 hours per day. That would happen after 10 days. I think 10 days of training, it would change. We would be covering Chef, Puppet, and Ansible. One of these tool we will cover in depth. Most probably it would be Ansible that we would be covering in depth. And Chef and Puppet, it would be an overview, right? And comparison with Ansible. It doesn't really matter. I mean, make sure that one of these tool you are pretty good with. That is, uh, that is the important thing. Yeah. So, any questions? So 9 p.m. Priya, so what time? There's a class which is going to start in the morning, but it will take time. Nearly 3 weeks it would take, Priya. So I would be informing the schedules and everything to your consultancy or your institute. Cloud computing is not mandatory for DevOps class, but actually, when you look out for a job change, I mean, most of this job profile would include you to know the Linux also. I mean, the cloud also. That is the reason we are covering cloud also. So, cloud computing is a important topic for a DevOps engineer. Cover two tools in depth. Yogesh, the thing is that it's not about covering. I mean, it's only one tool that you need to focus on. Nobody would insist you, neither the interviewer nor anyone would insist you to know more than one config management tool in depth. I mean, they would not find any ideal candidates who know two tools in detail. That is not important. But make sure that at least one tool that you are learning, you are a master in it. That is the important thing. So we would not be covering two tools in depth, only one tool in detail. The remaining tools, it would be a brief. Right? DevOps
Yeah,
does not
Basil.
mandatorily need to go with a cloud for platform. It can be applied anywhere. Whatever tools that we are going to learn, this is not specific to cloud computing or AWS. These tools can work with anywhere. It can be your on-premise data center. It doesn't really matter whether it is cloud or your on-premise. In real time, there can be sometimes it can be only cloud, sometimes it can be only your data center, or sometimes it can be hybrid Doesn't really matter. These tools that we are going to learn are not specific to any environment. Could you please share
Yeah,
today's
Basil,
class?
I have
Yeah,
a
I
question.
can share it with your consultancy, today's video. I don't won't be a problem. You can get it from them, Sumedha. So,
Yeah, Basil.
yes.
Basil, are you there?
Yeah, I'm here. Go ahead, Vikrant.
Uh,
I can hear you.
uh, I have a query. See, uh, scripting, where we can use it here,
Scripting?
where we are using here.
No, I didn't get you.
So here we are using shell scripting and Linux scripting.
Yeah.
We are using, right?
Yes.
So where this scripting will be used?
It depends. We are learning scripting because we are going to work with a lot of systems. Your tools, even sometimes from Jenkins you want to execute a number of script on the machines in your infrastructure, right? Sometimes you cannot do some work using these tools, you have to write your own script, then integrate the script with the tools. Or sometimes probably you want to write a backup script that would back up your databases and upload them into the cloud. So depending on your situation, there would be many cases you have to write some shell script, which is not actually a DevOps topic, but very important for a DevOps engineer. You must know at least one scripting to do some kind of automation, some manual automation that that cannot be achieved using a tool. You have to do it of your own.
Okay. Yeah, this course duration is around 1 month or 45
2 months.
days.
It will take 2 months. 70 hours is
So
the
is
actual
any
duration. So we will
okay?
complete.
Is any fast track batches?
Mhm.
Is any fast track batches is available?
No, it will take 2 months. That is the,
Okay.
but we will finish in 2 months. That is one guarantee. 2 month or maybe two
Uh,
month and 1 week or something in the worst case. That much time it will take.
okay. That's good.
So yeah, definitely. I can help you with some real time. What all work that would come in real time, I can help you with those. And that won't be a problem. And in morning, in IST morning, there are no batch starting for at least 2 weeks. I think after 3 week, a new batch would start at morning 7:30 a.m. IST. Till then, there won't be any new batches. Job assistance is something that you need to talk to your consultancy, but I would be available. You will get my mail ID, you will be able to contact me over email or maybe over phone also. uh, that shouldn't be a problem. But the job assistance is a different thing that you need to talk to your consultants. I would be available to answer any questions that you may have. If you have any doubt when you are working, those things I can definitely help you with, but not a job assistance.
Basil, Teja here.
Yes, Teja.
Do we have class today?
Yeah, we have class today actually. Just please hold on for
Okay, okay.
a couple of minutes more.
Okay.
We will
Yeah,
start.
no issues. No issues. Okay, okay.
So I'm looking if we can touch base. Yes, Sai Charan, yes, we can talk after the class. But right now I have to start another class, so we need to stop now for today. If you want to talk to me, just talk to your consultancy, get my phone number, and we can speak. Uh, yeah, resume preparation, I will be helping. I would be providing the sample resume that you can use, or maybe you can build your resume and get my help to verify it. Those things we can do. So yeah, actually, right now I need to connect to a different meeting. So I will talk to all of you. The classes would start from day after tomorrow. That means Thursday, same time. Yeah, thank you. Bye. Yeah, everyone else, Naga, Teja, please connect the meeting. Suresh, all of you. I'm just disconnecting this meeting. Connect again. Raj, you too. Thank you.